All right. Now, once you know all that, you then have to go and calculate currents and voltages in circuits, and sometimes resistances in circuits. And people find this quite difficult, so you need to remember your rules. In a series circuit, what happens? The voltage splits, and the voltage adds up, the two voltages add up to give you the total voltage of the battery, but the current is the same. So the same current flows through an entire series circuit. And a parallel circuit, it's the current that splits up through the branches and adds up again afterwards. But the voltage stays the same in every branch. So you remember those rules, and you should be able to work out voltages and currents when you need them. The other thing that's very, very useful to you is Ohm's law. And you can use Ohm's law for your entire circuit, or you can use it at individual bits of your circuit, provided you know the resistance of it and possibly the current flowing through it or the voltage across it. First question, calculate the total resistance in the circuit, the voltage across each resistor, and the current flowing in the circuit. So, the first part of the question, calculate the total resistance, and we just add them. So, RT is equal to 3 plus 3, and that gives you 6 ohms. Now, I'm going to do the current flowing in the circuit second, and I'm going to use V is equal to IR. So, the total voltage in the circuit is 12. We're looking for the current, and we now know the total resistance in the circuit is 6. So I'll put a comma in there. I is equal to V over R. And I is going to be equal to 12 divided by 6. So I must be 2 amps. So we now know we've got 2 amps of current flowing in every place through that circuit, through each resistor, and so on. Third part, we're going to find the voltage across each resistor. Now there's 2 ways of doing this. If the 2 resistors are equal like that, then it's very easy to say, right, 12 volts, they're equal, they must get 6 volts each. I'm going to use Ohm's law on one of them just to prove that the answer is 6 volts. I'll write down the answer first, 6 volts each, as they are equal. And V splits equally. Now you don't have to do this, but we're just going to check using Ohm's law, because sometimes that's not obvious if they're not equal, and you're better using Ohm's law. So if we have a look at this first 3 ohm resistor there, if I use V equals IR at that 3 ohm resistor, I know the current flowing through that now is 2. I know it's got a resistance of 3, and therefore it's got a voltage of 6. So if that's 6 volts there, and the total is 12, this must obviously be 6 as well. Alright, the next circuit I'm going to use here is my 2 3 ohm resistors again, but this time if I add another 3 ohm resistor in here. Now that changes the whole kind of current that flows through the circuit. So the amount of current coming out of the battery will depend on the amount of resistance that the current sees in the circuit. So the first thing we're going to do is calculate the total resistance. Now, I'm going to do the parallel bit first. I'm just going to do it over here. In parallel, I've got 2 equal resistors here, and therefore the total resistance is half of one of them. And so half of one of them is 1.5 ohms. So now I have an equivalent of 1.5 ohms here. If I just draw this, 1.5 ohms in series with 3. And so my total resistance there must be equal to 1.5 plus 3, which gives me 4.5 ohms. Right, again I'm going to do my current next. So there's the resistance there. I'm going to do current. So current is equal to V over R. Total voltage is 12. Total resistance is 4.5. And so you just divide 12 by 4.5. And you don't get a very nice answer. It's 2 2/3 or 2.67 ohms. Sorry, that's amps, of course. Current is in amps. And then the last part, we have to find the voltage across each resistor. Now, this isn't obvious. This part has got 1.5 ohms of resistance. This part is 3 ohms of resistance. It's going to take more voltage to push the same amount of current through here. So you have to decide what way you're going to do this. And we're going to have to use V is equal to IR. So I'm going to do the parallel bit first. Now, I know my total parallel resistance is 1.5 ohms. If I can find my voltage across that parallel bit, that's the same voltage across each bit in parallel, if you remember the rule. So I'm going to find this bit first. So V is equal to I times R, which is 2.67, or 2 2/3, multiplied by 1.5. And that gives an answer of 4, and it's volts. So that means there's 4 volts across here, and 4 volts across here. So if there's 4 volts of the 12 volts having been used here, I'm going to write 4 volts here. Then what's left? And you have got 12 took away 4, and that must give you 8 volts there. Now the idea of that, I know that you might think, well, 4 volts there, 4 volts there, that makes 8. So 8 away from 12 gives you 4. But in fact, that 4 volts is across the whole thing. And this is the idea of, if you remember, about the water at the top of the hill and getting 2 paths to flow. It's where they start out from, which it gives you your potential, in this case, difference. And so those 2 branches are both starting at 4 volts. And that's the push that is given the current. Remember, the current splits up here. And so the current is splitting up to get through these 2 resistors. So the single 3 ohm resistor has got a voltage of, I'm just going to do 12 take away 4, gives us 8 volts. Or you could use V is equal to IR, and the current in this part of the circuit is, like this part of the circuit, 2.67 times 3, and that gives you 8 volts. So there's a number of different ways. Once you've started to do it one way, you may realise, oh, I could do this or I could do this, and that will end up that you can get the answer 2 different ways.